Hello guys, my name is Afif Ali Satman and here today I will present you my solution for the problem number 2122A. So I mostly do competitive programming and low level stuff, and my Codeforces profile is this. This is my Codeforces. This is my Codeforces profile. So let's begin. So now let's go to the problem, which is called aka the greedy grid. So go to this link. This is the link, and then read the problem statement. So here it says a path in a grid is called greedy if it starts at the top left cell and moves only to the right or downward, always moving to its neighbor with the greater value, or either if the values are equal. So we've got our definition for the greedy path. So what does it say? If it starts at the top left cell, so where's the top left cell? This is the top left cell and moves only to the right or downward. So the path can move only to the right or can only move downwards. So this is how we got our definition for all the path, greedy path, and it says the value of a path is the sum of the value of the cells it visits, including the start and end. Thus there exists an n into m. So this is the n. N is row and m is column. Is the columns. So thus there exists number of rows and number of columns grid of non-negative integers such that no greedy path achieves the maximum value among all downright paths. No greedy path achieves the maximum value among all the right path. So now we will summarize this problem and what it's trying to tell and what we want to solve. And this is a little bit tricky problem. You can see that I've got killed by the pretest 2 and then accepted. So let me switch to the laser pointer. What does the problem say in a summary? Given the grid size n and m, where n is the number of rows and m is the columns, the question wants to see if a grid given the rows and columns are big enough to trick something like the robot or human. But yes, they were only added to clear our brains, to clear the problem so that we can understand more. But yes, they are not in the statement. We can only move only to the right or down starting from the top left corner, as I showed you. And a path in a grid is called greedy if it starts at the top left cell and moves only to the right or downward, always moving to its neighbor with the greater value, or either if the values are equal. We are not gonna taking a look at the test case because they are the same, but yes, the values are different, but the principle is same. Now, what's happening in our sample test case? We need to trick the robot to take the greedy path. The greedy path must be valid, and its sum must not be greater or equal to our solution, which is the maximum solution of our. So let's revisit to clarify. Does there exist a nm grade of non-negative integers such that no greedy path achieves the maximum value among all downright paths? So this is what they want. For example, our input for n and m is 3. Where's the bastard? Input and n is equal to 3, m is equal to 3. I don't have a track drawing or trackpad. So now, here, what does the robot choose? And we need to note that the robot's choice is red X. So robot chooses 3 because yeah, it needs to start from the top left corner, and then 2 is lower than 5, so it chooses 5 because it's greedy, and then it chooses 1 because they're all the same. And then it chooses 2. And then it chooses 3. His journey ends. So, if we sum all of the x's, his solution sum is 14. But, what's the sum of our solution? The maximum and non-greedy. So, we also start at the top left corner, and we do not take this path. We are going to take the maximum solutionable path. So we go to 2 because we can only go downwards and right. And then we can go to 5 because that's also a very good big number, but yes, we are not gonna be greedy, and we choose 4, and then our journey ends at 3. So if we sum all of this, our solution is 17. So we trick the greedy robot to take the valid path with the shortest sum of the numbers. So 14 is lower than 17. So mission success. So we've understood that when we can trick the robot, when we cannot trick the robot. This case will be not able to trick the robot. Our choice is robot is equal to robot's choice. And yes, since the robot is greedy, and will choose maximum big number big number. So yeah, we need to take this in mind. So robot always starts at this location. 1 is low, we can choose that, also the robot, and he goes to 2. And then his journey ends at 9. Only possible valid greatest sum is 14. And yes, this is our choice as well. So this is 2 into 2. This is 2 by 2 grid, and if we 1 by 1 grid is absolutely easy, because yes, for example, let's take this out. For example, you start at this location and then your journey ends. So yeah, the robot is not an idiot that he will try to search for another path. And 2 by 1, so yeah, if we remove coolants, for example, and then the robot will do the same thing as well in this. So these are the test case and conditions the robot, so that we will be not able to trick the robot. So as you can see, we've registered 2 constraints and 1 successful constraint. If n equals 1 or m equals 1, we cannot trick the robot. So we shall output in the judge's case no. If n equals 2 and m equals 2, we can't trick the robot here too. So we shall output no here too. Otherwise, we can trick the robot. So we shall output yes. So now let's take a look at the input-output format. So as you can see here, time limit per test 1 second. So we need to use fast input. Output is not necessary, but output is not necessary. So now each test case contains multiple test cases. The first line contains the number of test cases t. Idiotic constraints. The description of test cases follows. The only line of each test case contains 2 integers, n, m. And m, the number of rows and number of columns in the grid respectively. For each test case on a separate line, output yes if the required grid exists and no otherwise. Yes, we do not need this. So there's an example for 3 by 3. So now let's go ahead and start coding. So since the time is 1 second, so we are going to import sys, and input shall equal to integer sys.stdin.readline. T shall equal to integer input. For I, or underscore if you want, because we are not using the I here, in range T. n comma n is equal to map the objects integer input split split. Now this is we take the input of n and m. Now if we look at our constraints, we are gonna implement this all of this into an if and else statement. So yes, if n is equal to 1 or m is equal to 1, or this we can use another elif, but yes, for the sake of the code size and simplicity, we are gonna do this instead. N is equal to 2 and m is equal to 2, because we cannot put here or, because n is equal to 1 or m is can be equal to 2, because we've already used an or statement here. Addition we must not use or, because already done that in the first condition. Print no, otherwise print yes. So now our solution is done. Let's test it with a sample input. Oh, yes. Let's give him okay. What the hell? Let's interrupt this. 2 3 yes, 1 2 no. Says we've received the output yes and no, so we are good to go. And let's test another one, test case only. No. Let's test another one. 2 3 yes, because yes, we can trick the robot. 1 3 1 sorry 1 3 1 no. And finally one test case no. So yes, we are good to go, and we are gonna submit this and see what it says. Sorry for the delay, because yes, I was called. Since we've saved the file, and let's submit and wait for the results. Accepted. So yeah, thanks for watching, and remember, Codeforces, my own operating system, is coming, so like and subscribe and stay tuned. Thank you.